G'day, welcome back to another SolCube tutorial, and in this one we'll be diving into generating some circles using Unity's line renderer. I'll have the code to copy and paste in the description if you're just looking for a quick fix, but if you'd like to step through the coding, continue watching and we'll do some grade 9 maths. The code is based off this forum here, so credit to this dude. I've just created a new script called circle and I have an empty awake and start function waiting for me. So the first thing we want to do is declare some of our variables, starting off with a reference to the line renderer component. Then, we want to get a float to control the radius size of our circle, which is usually not applicable if you're generating these circles with dynamic sizes at runtime, but we'll use it for this application now. Then finally, we'll need an integer which controls how many points there are around the circle. Sorry to blow your minds, but a circle is really just a bunch of points connected by tiny lines. This value will sort of control the resolution of how small we want these lines to be. Next up, we just want to set up our line renderer component. First, grabbing the reference, so make sure you put the script on an object with a line renderer on it, and then adding some points to that line at runtime depending on how high resolution we wanted the circle to be. You're going to also have to add this third line here, which makes sure the line renderer is not using WorldSpace. It is actually generating the circle around where the game object is. We're then going to whip up a GenerateCircle function, and when adapting the script into your own projects, you'll probably want to take the radius in as a parameter here for a different size circle generation at runtime. For now, we're just going to declare some variables that will dictate the position of each point in the line to form the complete circle. We're also going to need a float to represent the angle as we move around anti-clockwise, setting our point positions. Now, breaking that down, we're going to loop through each of our points on the line and place them in the shape of our perfect circle. To do this, we'll need to first off create a for loop. In Unity, if you hit tab after typing for, it'll automatically bring up the scaffold for the syntax. Little handy tip there. For our length, we want to be looping through the amount of points on the line, which is the same value as what we set in our awake function, the fidelity counter plus 1. Now, to calculate the position of each point around our perfect circle, we're going to have to do some basic trigonometry. Let's throw our desired circle onto a Cartesian plane. And is this triggering any high school memories? We'll be using the unit circle to calculate points given our angle, which will gradually rotate around to form the full circle. The radius of the unit circle is 1, so when we draw on our axis like so, and use our basic trig identities, whoop-de-doo, would you look at that? From this we can conclude that the coordinate points for this point is simply cos theta sin theta, and that remains true for all the points around our circle. However, remember that we just shrunk the circle down to have a radius of 1? Yeah, well, now we just need to scale it back up again by multiplying whatever our values were by our desired radius. 1 times the desired radius is going to be the desired radius. And, just like that, we're laughing like a fat spider. When we're translating this into code, we need to remember to convert our degrees into radians, as that's what the trig functions in C# take as parameters. Also, for some reason I mixed the X and Y up in the code on your screen. It won't make any difference in functionality due to the symmetrical nature of a circle, but just so the math is correct, please swap them around to look like this instead. Next, we want to set the position of the point at the index of I in our loop to whatever our calculated X and Y coordinates were. Then finally, as we're about to loop back into the next point, we need to increase our angle equal to 360, which is the full rotation of a circle, divided by our point fidelity. This will slice up the circle so each point is spaced evenly. If we had a point fidelity of 36, it would place points in increments of 10 degrees. If we call this GenerateCircle function in start as an example, we can now go configure stuff in the editor and she should be working. Make sure your line has a material, and if it's a bit jagged because of a square material, you can increase the end cap vertices to smooth that out. And that's a wrap. This same code can be used for generating ovoid shapes as well. When you're setting the position of the points around the circle, if you multiply the x value by a different constant than the y, you'll skew the shape. Thanks for watching, and remember, if you need any further assistance, you can join the community server. Like, share, and sub, and we'll catch you in the next one. Peace.